Hello and welcome to another quick and easy math video, rate of change using differentiation. Now, any quantity that changes with respect to another quantity can be represented as a function, like in the form of an equation. Say, for example, the relationship between height of a growing child and its age. Say, for example, up until age 18 or around about there, we keep growing, and thereafter we play the height plateaus because we stop growing. So this can be represented as an equation which can be represented in the form of a graph. So for today's example, we're going to consider the number of kangaroos counted in a certain area every month. So N is a number of kangaroos and T is a number of months at which we count the number of kangaroos in the area. That function is represented by the equation n of t is half t squared plus 2t plus 35. Now, examining this quadratic function, we can see that it's a concave down parabola because a is positive. It's a concave down parabola. And we can determine the turning point of this particular function using x equals negative b over 2a. Negative b is negative 4 over 2 times a is 2 times half, which is equal to negative 4. So the lower turning point happens at x equals negative 4t, then month is negative 4. It's negative because we have not started counting the number of kangaroos yet. We are only starting to count the number of kangaroos at 0. So this part of the graph is obsolete for us. This left-hand side part is obsolete for us. We have started counting the kangaroo at 0, 1, 2, 3, 4 months and so on. So when we started counting the kangaroos, t was 0 and the number of kangaroos n of t was 35. That's what the y-intercept tells us. So going back to the equation, we can examine this graph and see that rate of change of any quantity with respect to another quantity is in fact the gradient, change in y over change in x. Using differentiation, when we differentiate a function, we get the gradient of that particular function. So we differentiate n of t to get n dash of t using the power rule, and we get the rate of change of the number of kangaroos. Now, what is the rate of change at, say, when the month is t equals 0, 3 equals 3? We substitute n dash of 3. We go back to n dash of t and substitute 3 wherever we see a t. So t plus 4 equals 7. And we know that when the differentiation of a function is greater than 0 or positive, then the function is increasing at that point in time. So at 3 months, the number is increasing. We can use the same method to determine the nature of the spread of a virus. Say if it's an exponential function, we can have the exponential function here. We can differentiate it and we can find out the projection approximation, we can call it, in 3 months time, 6 months time, and so on. So once we know the given function, we can differentiate it to find the rate of change, and we can substitute any particular time in order to determine the nature of that particular function, whether it's increasing or decreasing at that point in time.